Hello and welcome. In this video, we're going to talk about how to solve equations that involve radicals, how to check for extraneous solutions and what an extraneous solution is. We're going to talk about how to involve inequalities that also have radicals. And lastly, we're going to talk about how to solve exponential equations. So let's go ahead and jump right in. We've solved a lot of different kinds of equations. We have solved quadratic equations, linear equations, we solved polynomial equations. So those strategies that we have used for different kinds of equations, they're still going to come into play. We're just going to extend that idea a little bit in this section to the type of functions that we have been focusing on. So we're going to talk about solving a radical equation. A radical equation is an equation that has a radical in it, a square root, a cube root, a fourth root, but our variable, our independent variable, our x, is in the radicand, the inside part of the radical. And these steps are going to sound really familiar. The very first thing we're going to do is we're going to isolate the radical. We're going to isolate the part that has the radical. Then, after we do that, we're going to raise each side of the equation, because do unto one side as you do unto the other, to the same exponent. Whatever exponent is going to get rid of that kind of radical. What I mean by that is if you're trying to get rid of a square root, you're going to square both sides. If you're trying to get rid of a cube root, you're going to cube both sides. You're going to raise everything to the power of the exponent that is the inverse operation. That will get rid of the radical, and it will leave you with something that you already know how to solve, either something linear, something quadratic, or some other polynomial equation. So after you've gotten rid of your radical, then you can solve the resulting equation using those techniques, isolating x and solving. Your final answer should be in set notation, and you're going to make sure that every time you solve one of these problems that you check to make sure your answer is correct. So let's focus on each of these steps. I'm going to color code the same way that I did up top there. So the very first thing I need to do is I need to isolate the radical. So I'm going to go ahead and just sort of go over this radical in red. This needs to be isolated. So I'm asking myself, what is currently preventing that square root of x plus 1 from being by itself? Well, what's preventing it from being by itself is this 2. And what are the 2 in the radical doing? They're multiplying. And how do I undo multiplication? I use division. So to get rid of that 2 in front, I'm going to divide both sides by 2. So the square root of x plus 1 is going to equal 2. I have now accomplished my first step. I have the radical all by itself on the left-hand side, and I have everything else on the right-hand side. Now, what I'm going to do to get rid of the radical is I'm going to raise both sides to the second power. Why the second power? Because to get rid of a square root, I need to square something. When I square the square root, those inverse operations are just going to leave me with x plus 1. And on the right-hand side, if I square 2, 2 to the power of 2 is going to be 4. Now, the resulting equation is something we can solve easily by isolating x. So I'm going to subtract 1 on both sides, and that's going to give me that x is equal to 3. Now, for each of these problems, we're going to check to make sure that our answer is correct. And I can do that. I'm just going to come off to the side over here, and I'm going to write check. I want all of my work to be followable on the left-hand side, because it's sort of like I'm writing a math essay here. I want you to be able to read and identify what's happening in my work. So over here, I'm identifying, hey, I'm going to check that my answer works by writing check on top. So 2 times the square root of, we said x was 3, plus 1. This is supposed to be 4, so let's simplify. 3 plus 1 is 4. 2 times the square root of 4 is the same thing as 2 times 2, which is 4. So our answer is correct. So I'm going to come back. I'm going to put set notation around my answer, and I'm done. Now, looking at number 2, I want you to ask yourself, what is the term that needs to be isolated? Then I want you to ask yourself, what power am I going to have to raise both sides to? So hopefully you had time to think through those questions. The term that I need to isolate is right here. I need to get this by itself. So in order to do that, I need to get rid of this minus 1, I need to get rid of the 4, and I need to do that using inverse operations. So go ahead and pause the video and try and isolate that radical on your own. All right, hopefully you had time to do that. To isolate this radical, the first thing I'm going to do is add 1 to both sides, which is going to give me 12. 11 plus 1 is 12. And then I'm going to divide both sides by 4 to get rid of this 4 in front here. So 2x, the cube root of 2x minus 9 is going to equal 12 divided by 4, which is 3. So I've accomplished step 1. I've isolated my radical. Now I'm going to raise both sides to the appropriate power. If I'm trying to get rid of a cube root, I need to cube both sides. I need to raise both sides to the power of 3. When I cube the cube root on the left-hand side, all I'm going to have left is 2x minus 9. On the right-hand side, 3 times 3 is 9, times 3 is 27. And now I'm left with another linear equation that I know I can solve by adding 9 to both sides, which is going to give me 36, and then dividing by 2, which is going to give me 18. Just like before, I'm going to check and make sure my answer is correct. So I'm looking at 4 times the cube root of 2 times 18 minus 9 on the inside of that radical minus 1. So 4 times the cube root of 2 times 18 is 36. 36 minus 9 is 27. The cube root of 27 is 3. 12 minus 1, because I'm going to multiply that 4 and 3. This is going to give me 11, and I was supposed to get 11. So my answer is correct, and I'm going to go ahead and write it in set notation. So it's really important that you can isolate the radical term, that you can identify what power you need to raise both sides to get rid of the radical, and that you can solve the remaining problem. Sometimes you might have something linear like we had here, and what you're going to see in some more of our examples is you might also have something quadratic that you may have to solve by factoring or by using completing the square or the quadratic formula. So let's look at a couple more complicated problems. All right, here we go. Let's go ahead and look at number 3. So we have the radical is isolated. It's the only thing on the left-hand side of the equation. So step 1 has already been accomplished for us. Step 2 is to raise both sides to the power. So this is a square root. That means I'm going to square both sides. Just as a reminder, x plus 1 squared is equal to x plus 1 times x plus 1. That needs to be multiplied out either using the distributive method or using the box method or knowing the property of perfect squares that allows you to simplify it. So however you need to go about simplifying that, x plus 1 quantity squared is equal to x squared plus 2x plus 1. The square root of 7x plus 15 squared is just going to be 7x plus 15. Now, unlike the problems that we just had, what's left isn't linear, it's quadratic. I can tell it's quadratic because there's a term to the second power. So I'm going to move everything to the same side. So I'm going to subtract 7x and 15. That's going to give me x squared minus 5x minus 14 is equal to 0. How can we solve a quadratic? We can factor, complete the square, or use the quadratic formula. This looks like it's going to factor. So I'm asking myself what multiplies to be negative 14 that adds to be negative 5. So x minus 7, x plus 2. That's going to give me 7 and negative 2. It makes sense that I'm getting two solutions when I solve a quadratic. But does it make sense that both of them work? That's another reason we need to check our solution. So let's check. If x is equal to 7, I'm going to get 7 plus 1 equals the square root of 7 times 7 is 49 plus 15. So 8 is equal to the square root of 64. That works. Let's check what happens if x is equal to negative 2. Negative 2 plus 1 is equal to the square root of 7 times negative 1 is negative 14. 7 times negative 2 is negative 14 plus 15. So this is saying negative 1 is equal to the square root of 1. Well, that's not true. Yes, I can square negative 1 to get positive 1, but the square root here is indicating we are looking for a positive number on the left-hand side. This says square root. There's no plus or minus in front, indicating whatever sign is in front, a positive, is the type of answer that we're looking for. So we can't say that the square root of 1 is negative 1. This solution doesn't work. So even though I originally found two answers that work, only one of them is my solution. The other one actually has a special name. It's called an extraneous solution. When a solution that we find doesn't work when it's plugged back in, it's called an extraneous solution. And this happens because the way we're going about solving when we square both sides, we're opening the door for situations that don't match what the original function is doing. This original function was looking for a positive value on the right-hand side. This problem over here is looking for a positive value on the left-hand side because there's not a negative sign in front of that radical. That's why it's so important that we check that our answers actually work in the original equation. That's called checking for extraneous solutions. So make sure anytime you solve that you are going through that process to check and make sure what you solved works. Okay, let's look at number 4. The first thing we need to do is isolate this square root. Well, it's already isolated. So the second thing we need to do is raise both sides of the equation to the second power so that we can get rid of that square root. So on the left-hand side, we're going to have 2x plus 7. Remember, x minus 4 squared means x minus 4 times x minus 4. And if you expand that perfect square, you're going to get x squared minus 8x plus 16. Now, in order to solve for x, we're going to get everything on the same side. So I'm going to subtract 2x on both sides, which gives me x squared minus 10x. I'm going to subtract 7 on both sides, which is going to give me positive 9. And then I'm going to go ahead and factor. That's going to give me two solutions, 9 and 1. Now I need to check and make sure that both of these solutions work. So I'm going to check x equals 9. The square root of 2 times 9, well, 2 times 9 is 18, plus 7 is supposed to be equal to 9 minus 4. Well, this is 25. The square root of 25 is 5. 5 does equal 5. So that's definitely one of my answers. Let's see what happens when we plug in 1. On the left-hand side, I'm going to end up with the square root of 2 plus 7, or the square root of 9. On the right-hand side, I'm going to get negative 3. That's not going to work. This problem was not asking me for a negative square root. It was asking me for the positive square root. So x equals 1 is an extraneous solution. So my final answer is only going to include the value that works when I substitute it back into the original problem. So even though I found two solutions, one of them was extraneous, therefore my solution is just the one number that works in the original equation. Now, before we move on to a little more complicated radical equations, we're going to look at an application problem about hurricanes. All right, here we have a velocity model. We have a function that models the velocity in a hurricane that is sustained. So in a hurricane, the mean sustained wind velocity, so this models the velocity of our wind in meters per second, where P is the pressure, the air pressure in millibars at the center of the hurricane. So we're given a function, it's a square root function. We're being given a relationship between air pressure, P, and the velocity at a particular air pressure. The question says, estimate the air pressure at the center of the hurricane. So we're trying to find P when the mean sustained velocity, so we're being given the velocity, V of P, is 54.5. So 54.5 is our velocity. That's going to equal the function that we have already been told. Now we just need to solve this square root function. So go ahead and grab a calculator and pause the video and try and work through this problem on your own. Then unpause the video and see how you did. So to isolate our radical, we're going to divide by 6.3. So 54.5 divided by 6.3 is equal to the square root of 1013 minus P. I'm actually going to wait until the very end to use my calculator, so I'm not going to simplify this yet. To get rid of the square root, we're going to raise both sides to the power of 2. That's going to mean that 54.5 over 6.3 squared is equal to 1013 minus P. Now, if I solve for P, I'm going to get that P is equal to 1013 minus 54.5 over 6.3 squared. And now I'm going to go ahead and grab my calculator and figure out what that value is. And that's going to give me 0.137, so I'm going to say 0.164. And as always, we should answer our question in a complete sentence. So I'm going to say the estimated air pressure when the velocity is 54.5 is 938.164 millibars. And there we have it. So don't freak out just because you see word problems. We're really just practicing the same skills that we were working with before. Now let's look at another kind of problem where we need to solve a radical equation. Okay, so now I want you to notice with these examples, we have more than one radical. So there's a radical on the left and a radical on the right for both of these types of problems. What that means is the first step that we talked about with the earlier problems of isolating the radical, that doesn't really make any sense here. I can't isolate the radical because there's more than one. So how do we adjust those steps if we are solving a radical equation with more than one radical? Instead of isolating, we're actually going to start at our second step, or what was our second step for the other type of problem. We're going to raise each side to the exponent that we need to eliminate the radical. So square a square root, cube a cube root. Then what we have left, we're going to try and solve. It is possible and likely for a problem like these that after you square both sides, you're still going to have a radical. So you may have to repeat some of these steps. And I'll show you what I mean. If I look at number 6, the very first thing that I need to do is I need to square both sides. Now the right-hand side is really easy to square. The square and the square root are going to undo each other, so I'm left with 3 minus x. The left-hand side is a little bit more complicated. What we're saying is the square root of x plus 2 plus 1 times the quantity square root x plus 2 plus 1. If we multiply this out, we're going to get square root of x plus 2 times the square root of x plus 2 is x plus 2. Square root of x plus 2 times 1 is the square root of x plus 2. And then we're going to do the same thing down here. So I get another square root x plus 2, and I get 1. Let's go ahead and combine like terms. Well, I have just one x. I have 2 and 1, so that makes 3. And I have 2 of these square root x plus 2's. So I can rewrite all of that over here, x plus 3 plus 2 times the square root of x plus 2. Here's what I want you to notice. We now still have a radical, but when we originally had 2, now we only have 1. So right now, we're going to do exactly what we did on the first examples. Isolate the radical, square both sides, and solve for x. But we had to do it twice. We already squared both sides. Make sure the most challenging part, I think, is dealing with this multiplication. So make sure you're going slow and taking the time to multiply this out correctly. Otherwise, you're not going to get to the right answer. So before we even finish number 6, I'm going to encourage you to pause the video and work on squaring both sides here and simplifying to see what you get. Then go ahead and unpause the video and see how you did. All right. Hopefully you had time to expand out that binomial, and it's not the prettiest, but it does expand, and you can check your answer. Go ahead and pause the video and make sure you got that part right. Now that we've worked past really the only new step, what we need to do now is we need to isolate our radical. So on number 6, I need to subtract x and I need to subtract 3. That's going to give me 2 times the square root of x plus 2 is going to equal negative 2x. Those 3's are going to become 0, and the x and the negative x and the negative x is negative 2x. Now to solve for that radical, I need to divide both sides by 2. So I'm left with the square root of x plus 2 is equal to negative x. Go ahead and pause the video and isolate the radical on the right-hand side. Okay, for number 7, hopefully you subtracted x and subtracted 7 on both sides. That's going to give you 2 times the square root of x plus 6 equals, the 7's are going to add to be 0, negative 2x. And we're again going to divide by this 2 in front, so the square root of x plus 6 is going to equal negative x. What do we do next? Next, we need to square both sides to get rid of our radical, just like we did before. Then we need to get everything on one side and solve the equation that remains. So go ahead and pause the video and square both sides for both number 6 and number 7. So on number 6, that's going to leave me with x plus 2 is equal to x squared. And on number 7, x plus 6 is equal to x squared. So now I can move everything to the same side of the equation, and I can solve these quadratics by factoring. So go ahead and pause the video, solve by factoring, and then unpause the video and see if you got the same solutions. So hopefully you had time to work through both of those. Now that we have our solutions, we need to check our answers. So go ahead and pause the video and check your answers for numbers 6 and 7. So for number 6, when we substitute -1 back into the original equation, we get a true statement. When we substitute 2 back into the original equation, we get a false statement. That means that 2 is an extraneous solution, and x equals -1 is our entire solution set for this problem. For number 7, we get an extraneous solution with x equals 3, but we get a solution that works with x equals 4. So 3 is extraneous. -2, sorry, I said x equals 4, but x equals 2 is our solution. So now that we've talked about solving radical equations, let's see how this might be adjusted if we're solving a radical inequality. A couple of things to remember. With inequalities, if we multiply or divide by a negative number, we always need to flip that inequality. The other thing to keep in mind, our basic steps are going to be the same. Isolate the radical, raise both sides to the appropriate exponent, solve for x. The big difference is that we need to make sure, since we're looking at an inequality, that we don't forget about the domain restrictions. Remember that inside a radical, we always have to have a positive value if we're going to be working in the real number system, which we are. So for number 8, as we discussed in previous videos, x minus 1 is going to have to be greater than or equal to 0, which means x has to be greater than or equal to 1. I need to make a note of that so that at the end of the problem, I still consider that x has to still be greater than 1. No matter what I get when I solve, it still has to also be greater than or equal to 1. Similarly, for number 9, no matter what I get when I solve the inequality, x also has to be greater than or equal to 0, so that we're talking about real numbers. So now that we talked about our domain restrictions, which I like to identify at the beginning, but they also come into play at the end of the problem, we're going to isolate the radical and solve. So to isolate the radical on number 8, I need to divide both sides by 3. That's going to give me the square root of x minus 1 is less than or equal to 4. Now that I isolated, I need to square both sides. So x minus 1 is less than or equal to 16. Notice my inequality hasn't flipped because I haven't multiplied or divided by a negative. To solve for x now, I just need to add 1 to both sides. So I know that x is less than or equal to 16. But what else did we say about x? X can be less than or equal to 16, but it also has to be greater than or equal to 1 in order for us to have positive numbers inside the radical. So my final answer needs to include that restriction as well, less than or equal to 1. And I'm going to go ahead and write that as an interval. So every number between 1 and 16, including 1 and 16, will give me a real solution to this inequality. So 2, 1/2, pi, e, 15, all of those numbers would work as long as they're within this interval. Go ahead and pause the video and try and work through number 9 on your own. All right, hopefully you had time to work through number 9 on your own. We're going to add 4 to both sides, then divide by 3. Now I've isolated the squared part, so I'm going to I isolated the square root, so I'm going to square both sides. So x has to be less than or equal to 16. It also has to be greater than or equal to 0. So I'm going to take that compound inequality and I'm going to write it as an interval. So again, this lower part here is coming from the fact that we have to have a positive value inside our radical. Now that we've talked a little bit about inequalities, let's talk about one last thing, sort of tying some things from previous lessons together, and we're going to talk about solving equations that involve rational exponents. All right, so we've done a little bit of this before. The new part is that it's not just an exponent, but it's a rational exponent. But steps are going to feel really similar to what we were just doing. Isolate the exponential term. Then we're going to take the nth root of both sides. I'm going to actually add something that I'm going to encourage you to add. What we can also think of this as is we're going to reciprocate the exponent, and we're going to raise both sides to that power. What that means is if we're solving something to the 1/2 power, we're going to raise both sides to the 2nd power. If we're solving something to the 2/3 power, we're going to raise both sides to the 3/2 power. That way, our exponents, power to power, multiply to be 1, which will allow us to eliminate them. So, isolate the exponential term, take the appropriate root or raise each side to the appropriate power, and then solve. Let's look at number 10 together. I'm going to subtract 2 from both sides. That's going to give me this. Now, I'm going to raise both sides to the power of 4/3 so that when these two exponents multiply, I get 1, which means I just have 2x. Now, 8 to the 4/3, we learned already how to simplify. You can make the upside down birthday cake, or you can just rewrite 8. What is 8? 8 is 2 to the 3rd power. I'm actually going to do that in blue so you can see this is still just 8. That's going to be to the 4/3 power. And if I simplify that, I just get 2 to the 4th, which is 16, which means that x is going to be 8. And then we should check to make sure that this answer does, in fact, make sense. 2 times 8 to the power of 4/3 plus 2. 16 to the power of 4/3 is 8, plus 2 is 10, so this does work. Looking at number 11, we already have our radical or our rational exponent isolated, so let's raise both sides to the 2nd power because 2 times 1/2 gives us 1. So we're going to have x plus 30 equals x squared. Now, just like we did with radicals, get everything on the same side and solve. This is a quadratic, and it's a quadratic that factors. X minus 5, x plus 6 equals 0, x equals 6 and negative 5. And we need to check those answers. So go ahead and plug those in and check. So remember, to the 1/2 power is the same thing as the square root. So negative 5 plus 30, the square root of that, is not going to equal negative 5 because I'm looking for the positive version. So that's an extraneous solution. The square root of 6 plus 36 is going to equal, the square root of 6 plus 30 is going to be the square root of 36, which is 6. So that solution is going to work. I'm going to encourage you to pause the video, use 10 and 11 as your guide for 12 and 13, and then we will go over them together after you finish. Okay, so for number 12, I added 2 to get 27, then I raised both sides to the power of 4/3, remembering that 27 is the same thing as 3 to the 3rd power. That way, I can multiply those exponents to get 3 to the 4th, which is 81, and then solve that to get that x is 27. On 13, I squared both sides to get rid of to the 1/2 power. So x plus 12 is x squared. I moved everything to the same side and I solved that quadratic. Now, the only thing that's missing from both of these problems is checking that my solutions actually work. So I'm going to go ahead and do that. So when I check on number 12, I do get an answer that works. On number 13, only one of my answers works. Negative 3 isn't going to work, so my solution set is just going to be x equals 4. So key ideas in this section, whether we're talking about radicals or rational exponents, we need to make sure we're isolating the appropriate radical or rational exponent, raising both sides to the power that we need in order to get rid of that radical, and solving what remains, whether that's linear, quadratic, or a polynomial function. If we have inequalities, we need to make sure that we're considering the domain of the original function when we're writing our interval as our answer. So we focused on solving radical equations, solving radical inequalities, and solving exponential equations with rational exponents. Go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.